Hello to my dear children over there. Today we are going to learn law of conservation of energy, which is very much similar to law of conservation of mass. So if you like this video, please don't forget to click on the like button and share it with your friends. Law of conservation of energy states that energy can only be converted from one form to another. It can neither be created nor be destroyed. But the total energy before and after the transformation remains the same. That means we are not able to create energy or we are not able to destroy energy. But what we can do, we can convert one form of energy into another form. We can transform energy, isn't it? One kind of energy can be transformed into another kind of energy, and whatever be the transformation, the total energy remains the same. Suppose looking at this example, we can explain this, that is electricity is coming through this conducting wire, that is electrical energy. This bulb is getting electrical energy. When this electrical energy reaches the filament of this bulb, what happens? This filament will be producing heat energy, that is heating effect of electricity. When electrical energy passes through this filament, you can see the filament over here. This is the filament. So what happens, this filament will be producing heat energy and light energy. So this electrical energy has been transformed into heat energy and light energy. So when we calculate total energy produced, this, that is heat energy plus light energy, that will be equal to the total energy consumed, that is electrical energy. How much electrical energy is consumed by this, that will be equal to the heat energy plus light energy. And it is not losing anymore. That is law of conservation of energy. Energy is not going to create it, not going to be destroyed, but we can transform, we can change, we can convert one form of energy into another form. Just like we are, the plants are during photosynthesis, the plants are trapping sunlight, isn't it? Solar energy will be converted into chemical energy while they prepare the food, glucose. Okay, when we talk in a mic, when we talk in a microphone, what happens? That will be the sound energy will be converted into electrical energy. And from the speaker, the electrical energy will be converted into sound energy. We are able to hear the sound from the speaker. What kind of transformation is happening? The electrical energy is converted into sound energy. So different when you switch the fan on, what happens to the leaves of the fan? The blades of the fan will be rotating, that is the electrical energy will be converted into mechanical energy. That is mechanical energy in the sense it is getting kinetic energy. Kinetic energy is one of the mechanical energy, isn't it? Though the blades of the fans get kinetic energy. So in this way we can explain this law of conservation of energy by using different examples. Now another example is given here, nuclear energy. From the nuclear energy electricity can be produced, and this when this happens, light energy also will be produced. So when this chemical energy which is stored in the atoms, that can be converted into the nuclear energy, and that can be converted to light energy. And this example we have already explained, battery. From the battery, chemical energy will be stored in the battery, and from this battery it will be converted into electrical energy, and it will be flowing through this wire as electrical charges and reaching the bulb. Once it reaches the bulb, what happens? This electrical energy will be converted into heat energy and light energy. And another example, you can look at the picture of the tree. Some fruits are there on the branches. So whenever these fruits are on the branches, they are having potential energy because they are at a particular height. You can see this position, isn't it? They are at a particular height, and whenever they are falling down, when these apple or whatever it is, the fruits falling down, due to the motion they obtain kinetic energy. So this potential energy which was there when they were at that position, that was transforming into kinetic energy. So while they move down, potential energy decreases while kinetic energy increases. So how do they get this energy for their movement? They get energy for their movement from the potential energy. The potential energy is the energy which is possessed due to the position. Since they are at a particular height, they possess some kind of energy. That is the potential energy. And this potential energy will be converted into kinetic energy and they acquire speed. And another example, conservation of energy in tossed ball. So here in these two examples and the previous example, we are only talking about potential energy and kinetic energy. So you know that this potential energy and kinetic energy, they are part of mechanical energy, isn't it? They are two divisions of mechanical energy. So this potential energy and kinetic energy are interconvertible. They can be transformed from one form to another. They can be converted from one form to another according law of conservation of mass. So here one person is tossing a ball. So what happens to the energy when he tosses the ball? As the ball drops from its highest point, when it reaches the highest point, it is having potential energy. When it moves high, it is having kinetic energy, and when it reaches high, it is having potential energy. And when it comes back, the potential energy will be reducing. At the same time, kinetic energy will be increasing, and it reaches at this position just below the surface. Mostly kinetic energy will be associated with it, and when it is on the halfway, half potential energy and half kinetic energy. So potential energy plus kinetic energy, that gives you the total energy. Now another example, same with the ball. The ball is moving through this pathway, and when it reaches at the maximum height, it will be having maximum potential energy and minimum kinetic energy. And when it moves down, the potential energy will get reduced and it will be converted into kinetic energy. So when it reaches at a position like this, just above the surface of the ground, it will be having maximum kinetic energy, that it will be moving with maximum energy, and minimum potential energy will be there. So whatever may be the examples, the total energy is equal to potential energy plus kinetic energy. Total mechanical energy is equal to kinetic energy plus potential energy. That is known as law of conservation of mass. Mass cannot be created or destroyed, but it can be converted from one form to another. Now, one numerical problem is there. We can solve this numerical problem. A girl having a mass of 35 kg sits on a trolley of mass 5 kg. The trolley is given an initial velocity of 4 meter per second by applying a force. The trolley comes to rest after traversing a distance of 16 meter. How much work is done on the trolley? How much work is done by the girl? Okay, one trolley is there, and inside the trolley one girl is sitting there. Okay, and what is the weight of the trolley? 5 kg, and weight of the girl is 35 kg. So what is the total weight? 40 kg. Okay, the trolley is given an initial velocity. So somebody is giving a push, that is force, isn't it? Force is applied on the trolley with the girl, and it is moved to 16 meter. It is moved to a distance of 16 meter, having a initial velocity of 4 meter per second. So here initial velocity is 4 meter per second, and final velocity v is equal to 0 because it comes to rest. So it stops its motion, so final velocity is equal to 0. Now we want to find out how much work is done on the trolley. So work W is equal to F into D, force into displacement, and we don't know the displacement, that is 16 meter. Now we want to find out F. F is equal to mass into acceleration. F is equal to ma. So we know the mass is equal to 40 kg because the girl is sitting in the trolley, but we want to find out the acceleration, that is not given there. Since the velocity is changing, obviously acceleration will be there. So in order to find out the acceleration, we can use this formula, v square minus u square is equal to 2as, because we know the values of all these except a. We don't know the value of a, but we know v square, v, the value of v, the value of u, and value of s. So just we can substitute the values in this equation. So we will get A is equal to V square minus U square divided by 2S, because we are keeping A on this side and we are taking 2 and S from this side to this side. That is, it will be coming as the denominator of V square minus U square, that is V square minus U square divided by 2S is equal to A. So what is the value of V? 0. 0 square, here you can write 0 square minus 4 square, that is equal to 16, divided by 2S. 2 into, what is the distance? 16 meter. 2 into S. 2 into 16, that is equal to 32. So here 16 and 16 can be cancelled, because 0 minus 16 is equal to minus 16 only. Minus 16 divided by 2 into 16. 16 cancelled, and we will get it as minus half meter per second square. Why this minus sign? Because the body is, when we apply a force, the body is going to stop its motion, isn't it? Stopping the motion, that's why acceleration, that will be deceleration. That's why it is having a negative sign, minus half meter per second square. So we can just apply this value in this formula. MA 40 into minus half, that is equal to minus 20 Newton. So the answer is F is equal to minus 20 Newton. Now we can just apply this value in the above formula for work. This is the formula for work. So we can apply this value in this work, that is F is equal to 20, D is equal to 16, 20 into 16, that is equal to 320 joules. And work done by the girl is equal to 0 joules. The girl is doing, she is not doing any work. She is just sitting inside this trolley. She is not doing any work. Actually work is done on her, on this whole system. So the girl is doing 0 work. So very simple, just understand the concept, then you will be able to do this. Now second one, a ball is dropped from a cliff, that is from a hillside. A ball is dropped. Find its speed 2 seconds after it is dropped, its speed when it has fallen through 78.4 meter, and the time taken in falling through 78.4 meter. So you will have to find out three things: its speed after, that is 2 seconds after it is dropped, its speed when it has fallen through 78.4 meter, and the time taken to reach 78.4 meter. All these things we can find out. That is velocity after 2 seconds. For which formula we can use for this? V is equal to U plus AT. Simple formula we can use to find out the velocity after 2 seconds. Okay, V is equal to U plus AT. V is the velocity after 2 seconds, that is equal to initial velocity. It is dropped from a certain height. So just before dropping, the initial velocity is 0. Then G, A is equal to G, that is 9.8. Because it is dropping from a certain height, the object will be possessing an acceleration 9.8, and into time. Time is 2 seconds. So the value is this one. V is equal to 19.6 meter per second. That is the speed or the velocity after 2 seconds. Now we want to find out the time taken. We want to find out the time taken when it is reaching through a 78.4 meter. So for that purpose we can use the formula S is equal to UT plus R half AT square. S is equal to UT plus half AT square So here this is 78.4. U. S is equal to 78.4. The distance traveled is 78.4. U is equal to 0. Initial velocity is 0. So this part will become 0 plus half into, we can, if you want, you can take G as 10 also, no problem. Half into 9.8 into T square. We want to find out the time by which it is reaching the 78.4 meter. Okay. So here we are going to find out t square from this equation. We are going to find out the value of t square. T square is equal to 2 into 78.4, sorry, 78.4 it is, divided by 9.8. So by doing this we will get t square is equal to 16 and the value of t is equal to root 16, that is equal to 4 second. T is equal to 4 seconds. So by 4 seconds it will be reaching 78.4 meter. Now one more question was what was that question? Velocity when ball has fallen through 78.4 meter. So that is the next question. What will be the velocity or what will be the speed when it reaches the 78.4 meter? Okay. So here let me erase this. Again we are using the same formula, v square minus u square is equal to 2as. By using this formula we are going to find out the answer by using v square minus or else I will be explaining here only. V square minus u square is equal to 2as. We use this formula. Here a can be changed to g and s can be changed to h because it involves height. So v square, we are going to find out v, isn't it? The velocity by which it reaches 78.4 meter. So v that we want to find out, and initial velocity when it drops, the velocity is equal to 0, that is equal to 2 into 9.8 into what is the height, 78.4. Now v square is equal to 2 into 9.8 into 78.4, that is equal to you will get this value as 1536.64. You can even consider 9.8 as 10 also. Okay. And v is equal to 39. We are taking the root of this value, that is 39.2 meter per second. So these are the three different sections of this question. First one is v is equal to 19.6 meter per second. Second, v is equal to 39.2 meters per second, and the time taken to reach 78.4 meter is 4 seconds. Okay. Now I'm giving you two questions. You will have to find the answer and write the answers in the comment box. A stone is dropped from the height of 120 meter high tower. Calculate its speed after 6 seconds. Find the speed with which the stone strikes the ground. So this height is equal to what? 120 meter, and time taken is 6 seconds. You will have to find out the velocity after 6 seconds and the velocity with which the stone strikes the ground. Second question, a body dropped from the top of a tower covers a distance of 7x in the last second of its journey, where x is the distance covered in the first second. How much time does it take to reach the ground? So think and do this and solve this problem and find out the answer and give the answer in the comment box. So thank you so much for watching this video. Bye children.